Okay, we're going to look at some more word problems, maximization word problems. So when we're maximizing, remember what we're looking for is the vertex, right? Maximizing. So this one here, we're talking about maximizing area. So we have a rectangular field. So I'm going to draw a rectangle here. Okay, is enclosed by a fence and is divided into two equal parts. Okay, so we got a line down the middle. So everything I've drawn here represents fencing, right? Fence going around the outside and a fence in the middle. Let's just call these longer ones. We'll use L for length and W for widths. All right, because we have three widths that are the same and two lengths that are the same. All right. Okay, so it says we have 1,200 meters of fencing available. Let's come up with some stuff for this. So what we need to do is we're maximizing the area. So I'm going to need two formulas here. Let's see what we can come up with. So formula number one, okay, is going to be our perimeter formula. There's two lengths plus three widths is equal to, how much fencing do we have? 1,200 meters there, right? Okay, so if you add together all the lengths and widths, we should get 1,200 meters. So there's equation one. We're going to need another equation though. We need to bring in area because that's what we're trying to maximize. That's the clue, maximizing area. Well, area equals length times width. So what we're going to have to do here is use substitution or elimination to put these two equations together. So let me walk you through the steps that I would do here. All right, so step one, we want to take equation one there, and let's isolate length or width. So let's isolate, it doesn't really matter, who do you want to pick? I don't know, let's isolate the length, okay, in equation one. Okay, so let's do that right now. All right, so step one, here we go. So what am I going to do? I'm going to take 2L plus 3W equals 1,200, and we decided to isolate L. It really doesn't matter which one. So what are we going to do? We're going to subtract 3W from both sides and divide both sides by 2. So it's going to be 1,200 minus 3W divided by 2, right? Or if you want, we could divide them each individually by 2 and make this 600 minus 3 halves W. All I did is divide the 1,200 and the 3W by 2 individually. All right, why don't we call that for now equation number 3, just so we can keep track of everything here. All right, step two. Well, this is the part where we want to put this into the area equation. Remember, we want to use substitution here. So what I'm going to do is I'm going to substitute equation 3, and that's why I'm numbering these. It's a lot easier to refer them by number instead of stating each equation, into equation 2 over here, our area one, right? All right, so let's do that. Okay, so we're going to go area equals length times width. Well, let's replace, right, length times width. Let's replace the length with this entire formula there. All right, so here we go. 600 minus 3 halves W times W. There you go. It's done. We substitute in. Not much else to it, right? Just to make it look nicer, I'm going to switch this around and put the W out front, minus 600, or times 600 minus 3 halves W. Now, what we have here is a quadratic equation. All right, so let's go to step 3. Step 3, once we have our quadratic equation, let me just write it up here at the top a little higher so I can conserve some room here. Step 3, we want to find our roots. Let's think about what is this thing going to look like here. I'm going to draw just a little rough sketch again here of what this could possibly look like. I'm really having to squeeze it all in here. But we've got a parabola that's going to open upwards, right? And it's going to look like this. Not the best. And we're going to have two roots again, right? A root here and a root here, and we want to find that maximum. So what are we using here? Look at our equation here. We're comparing area and width, right? So area is like my y coordinate. So when I'm looking at my vertex, right, the area is going to be the y coordinate. The width is going to be my x coordinate. So what width would I need to maximize the area? That's what we're looking for. So the first thing is let's find the roots, right? So step 3, let's solve for the roots. Now you can do the long way or the easy way. So remember, roots are x-intercepts, right? So they're going to be down here. One of them is going to be at something over 0 up, and the other one's going to be at something else over 0 up. Well, the good news about this one is, once again, it's in factored form like we had in our previous lesson. So what are we going to do? You set y equal to 0, right? In this case, area equal to 0, and solve. This thing's already factored. It's factored so simply that some people don't realize it, right? Set each of your factors equal to 0. So one of our roots is w equals 0. The other one, 600 minus 3 halves times w equals 0. Well, we're going to add 600 to the other side, and then we're going to multiply it by negative 2/3, right, to get rid of the negative 3 halves. So we're going to have w equals negative 2/3 times 600. So what's 600 divided by 3 times negative 2? And you're going to, oops, it should be negative 600, right? That should give us 400. So those are my two roots. There they are. So I'm going to write them down here. One's at 0, and the other one's at 400. So since that one's at 0, I'm just going to draw where my y-axis would be. In this case, my area axis, because this is w. We're comparing width and area, right? We've taken length out of the equation for now, right? If we look at our equation here, we're just comparing area to width. Maximize the area compared to the width. If we had isolated w here instead of L, we'd be comparing area and length. It really doesn't matter. All right, next step. I've got to really squeeze this in here. Step 4. We want to find the axis of symmetry, right? Remember, that gives us the x-coordinate of our vertex, which in this case, instead of x, we're using w. So add your two roots together. What's 0 plus 400 divided by 2? Shouldn't need much calculation to figure that out. It's going to be 200. All right, so the x value of my vertex is there at 200. And if I want to draw my axis of symmetry in, my middle, oops, well, it's off a little bit. Now you get the point, right? It's somewhere in there. Come on. Oh, man, eh? You just cannot get that thing to lay. Whatever. There we go. Good enough. There, I'll make that point bigger. That's it. Whoa, there's my dog barking. Sorry, had to pause. Dogs barking at dogs in the alley. All right, so where were we at? Now I'm lost. All right, so we got our axis of symmetry, right? 200, right in the middle. Okay, so now, how are we going to find our maximum area? Well, that's pretty easy. I'm going to move this up a little bit so we can see a little more. So we're going to lose a little bit of the lesson here. All right, so we just figured out the width is when we set the width equal to 200, that's going to give us a maximum area, right? That's where our vertex occurs. So step 5, let's just find the other measurements, okay? So find the other measurements. So what do I mean by that? I mean, what's the length? What's the area, right? We know the width has to be 200. So in my diagram here, I know each of these widths are going to be 200 meters, 200 meters, 200 meters. Well, what's the length going to be, right? I need the length. So don't we have a formula right here where we have length isolated? Length is equal to 600 minus 3 halves the width. All right, so let's do that. So I'm going to find my length. What's 600 minus 3 halves times the width, which we just found is 200. So 200 divided by 2, right, is 100 times 3 is 300. So what's 600 minus 300? There you go. You're going to get 300 meters. So now we got our length. We got our width up here. So our lengths on my diagram are each 300 meters, 300 meters. All of that should add up to be 1,200 if our math's correct. And what about the maximum area, right? Well, area is length times width, isn't it? So area is, my lengths are 300, my widths are 200, so my maximum area is going to be 60,000 meters squared. So I could answer a variety of questions here now, right? I know my length, I know my dimensions. Length is 300, width is 200, and the maximum area is 60,000 meters squared. All right, let me draw that on my diagram too. So my maximum area, if I drew this in here, would actually be 60,000 there. So it would be pretty high up. All right, so really we just did the exact same stuff we always did, right? Finding the roots, finding the axis of symmetry. It's just setting the equation up. And we're just going to do one more, and then that's going to be it for this lesson. Okay, this is another classic one, and there's a lot of variations on it, so we got to be careful because it's not just one size fits all, but they're generally the same idea. The idea is, okay, in this case, someone has a painting and they want to put a frame around it. Sometimes it's like someone's cutting a lawn and they got a border around it. Someone's got a sidewalk around a pool. The general idea is you have a big rectangle around a little rectangle with all these types of questions, okay? And in this case, she's got a painting, right? And it says her painting is 50 centimeters by 60 centimeters. So I know this is not super accurate, but we'll just put the 50 here and we'll put the 60 over here. Okay, there's the painting. So she wants to put a border around it, right? All right, so you know what, before I even get into that, let's just go through some basics. What's the area of the painting, right? Let's get that out of the way because that might come in handy in a minute. Okay, so the area of the painting, right? Well, area is length times width. So area length times width, it's going to be 50 times 60, right? So that's pretty easy. There we go, 30,000 centimeters squared. Wait, 3,000. I got too many zeros in there. 30,000. There we go, 3,000 centimeters squared. Okay, that's the area of the painting. We got that. Let's see what else they're giving us here. Before she placed the painting on the rectangular mat, she wants a uniform strip. So these questions always have the idea of there's this uniform strip going around the outside, whether it's the border around a pool, the border around the painting, the border around something. And every one of these, I'm just going to use X to represent that. So uniform meaning all sides, it's the same thing, right? Okay, so it's X. All right, so we got that. The area of, now here's the next thing. They say the area of the mat, this is always each question, this is where they're definitely a little different each time, right? In this case, it's saying the area of the mat. So they're saying the area of the entire thing that this painting is laying on, the big rectangle, this whole big rectangle here. The area of that is twice the area of the painting. All right, so that's pretty easy to find the area of the mat, right? Let me just write that here. We just need to double the area of the painting. So the mat is the entire big rectangle, including the area of that painting there, right? So its area is just 2 times 3,000. All right, so that's going to give us 6,000 centimeters squared. All right, so we got everything we need here, but we want to figure out what the length of X is, right? What is the width of that uniform strip? So what we have to do is we have to come up with a formula that includes that. So what we're going to do is let's focus on the area of the mat. All right, so I'm going to come up here and talk about the area of the mat. Now we already know it's 6,000, right? But let's write it in terms of length and width. So area equals length times width, right? All right, so we already know the area of the mat is 6,000. So I'm going to replace the A here with 6,000 centimeters squared. We know that. What we need is the length and width of this mat, the outside length and width. So let's start down here with, we'll just call this the length. It really doesn't matter. All right, now how long is this? Well, from here to here is 50 centimeters, right? And this is an X, and this is an X from here to here. So the entire thing would be 50 plus 2X, or if you prefer, 2X plus 50, right? So that's the length all the way across here, 50 plus 2X's, okay? So we'll call that our length. 2x plus 50. All right, let's do the other one, the width. Doesn't really matter whose length and width. All right, so let's think about that again. Well, this is X from here to here, right? From here down to here is 60, and then another X from here to here. So that means this entire thing would be 2X's plus 60. Oof, that's sloppy. All right, so that would be our width, 2X plus 60, right? Now, why did we write it that way? Because we're trying to create a formula that incorporates and includes the X, because that's what we want to solve for. All right, so now what we need to do, we're not looking for the maximum here, and this is what messes people up, right? We're not looking for the maximum. What would X be? What would you put into X? Then when you go 2 times X plus 50 times 2 times X plus 60, that would give us 6,000. It's not a 0 over there, right? We set that equal to 0 when we're looking for the maximum. This is different. We already have a set area. The area is stuck at 6,000. So we need to figure out what X is. So in this case, we can't just go, well, it's in factor form, let's find the roots, because this side is not 0, right? So what we're gonna have to do is simplify this thing. So I'm gonna multiply, 2x times 2x. We're just gonna expand, binomial expansion, 2x times 2x, 4x squared, 2x times 60 plus 120x plus 100x, and 50 times 60 plus 3,000. And I'm running out of room here. I got the 6,000 here, and we're going to get the 6,000 off the side by subtracting 6,000. I'm just going to shift everything over a little bit here, and I'm going to subtract 6,000 from the other side. So let's add these two together, actually, and let's make that into, add those two, 220x, and we got 3,000 minus 6,000, so minus 3,000. Now it's set equal to 0, right? So now we want to find our roots. So you can try to factor this. I don't think it's going to factor very well, or you can go use your quadratic formula. Now, if you want to make things just a tiny bit easier, everything here is divisible by, well, at least 2, but I think everything's divisible by 4. I can divide everything here by 4 just to reduce it a little bit, right? So when I do that, not mandatory, it just makes the numbers a little more manageable, right? Gives me 1x squared now plus 55x minus 750. That's a not mandatory step, but it helps. All right, so let's identify what's A. A is 1. What's B? 55. What's C? Negative 750. Now, I'm not even going to try to factor this. I'm going to go right to my quadratic formula. Here we go. X equals negative B, right, plus or minus the square root of B squared minus 4AC. And you should all be pretty darn competent with this formula at this point if you're in a grade 11 functions class. So let's sub everything in. Negative 55 plus or minus 55 squared, right, minus 4 times 1 times negative 750. And when you do your work, set it up like this. After this, you can kind of jump to your calculator if you prefer. All right, so I'm going to break it down here. I'm going to end up with negative 55 plus or minus the square root of, okay, once you square the 55 and go 4 times 1 times 750, add that to the 55, you're going to get 6,025, right, divided by 2. So there's two possible answers. What's negative 55 plus that? What's negative 55 minus that? Divide them both by 2. And when you do that, you're going to get two possible answers out for x. X could be equal to 11.3 centimeters, or x could be equal to negative 66.3 centimeters. Now, should be pretty obvious which one makes sense here. The negative one's out. We can't have a negative length. No way. So the only one that makes sense is 11.3, which must be our border width. So there you go. That's it. We found it right now. Here's the thing. People get carried away here and they start finding the root. We got the roots, but people start finding the axis of symmetry, and then they start trying to find the vertex. We're not finding the maximum here. We're finding what value of x. Go back to what we started with. What value of x goes here and here that equals 6,000? There are two possible answers. 11.3 can go in there, or negative 66.3, right? And we said negative 66 doesn't make sense, okay? So that's our final answer. Our final answer for the width would be approximately, right? So what does it say? How wide is the strip? So the strip width, right, is approximately 11.3 centimeters. There you go. Okay. All right, so that's all there is to that. Now, like I said, there's so many variations of this. We're going to try and keep it simple for now and just focus on ones like this for now. All right, thanks.